This is part 2 of a 5-part video series on local VFR and uncontrolled airfield operations. This lesson covers VFR pattern entries, radio communications, GPS navigation, VFR instrument approach procedures, and recovery back to Vance. On this flight, we will depart Vance Air Force Base and fly the pod stereo route, cancel IFR approaching pods, proceed to NTA Ponca City for VFR patterns and the ILS-17, then discuss departing the NTA and how to go to a MOA or back to Vance. Before we actually jump in a plane, let's discuss VFR arrivals. There are 3 basic ways to conduct a VFR arrival to an airfield: the downwind leg entry, the straight in, and the overhead pattern. A 4th way to enter the pattern in the T6 is by going to high key and spiraling down to the runway. We will talk about conducting ELPs at NTAs in the 5th video of this series. In this video, we are just going to be talking about the downwind entry leg and straight in approach. The most common VFR arrival to an NTA is the downwind leg pattern entry. This is the preferred entry method into the traffic pattern because it allows you to easily clear left and right of you and minimizes the time you spend belly up turning onto the downwind. The FAA encourages pilots to use the standard traffic pattern when arriving or departing an NTA, particularly when other aircraft is observed or when operating from an unfamiliar airport. The images here depict how to enter and exit the left and right-hand traffic pattern. Left-hand patterns are standard unless otherwise denoted for a specific runway. At Ponca City, runway 17 uses non-standard right patterns, as denoted by the RP-17 on the last line of the airfield information text. If you flew left-hand patterns to runway 17, you'd be flying low over a densely populated part of the town, southeast of the runway, which is not desirable for safety and noise abatement considerations. These images depict the airfield overfly to downwind entry method. A pilot may choose to overfly the airfield in order to enter the downwind leg faster, or to get a look at the windsock to determine which runway to land on. The overfly method is particularly common at airfields without weather reporting capability. The overfly method should be used with caution, however, when other aircraft are already in the pattern. To mitigate the risk of a midair with another aircraft, fly at least 500 feet above traffic pattern altitude. After overflying the field, consider flying 2 or 3 miles past the airfield before executing a turn and descent to enter the downwind. There are occasions where a pilot may choose to execute a straight-in approach for landing when not intending to enter the rectangular traffic pattern, such as a visual approach executed as part of the termination of an instrument approach. The straight-in is also helpful early on in flight training as it provides for a long, wings-level final which helps keep the aircraft stable during descent to landing. When performing a straight-in, the goal is to descend on a 3-degree glide slope. The 60-to-1 rule states 300 feet AGL for every 1 nautical mile from the runway equates to approximately a 3-degree glide slope. For the T6, when configured gear down and flaps takeoff, this descent profile typically equates to 5 to 600 feet per minute descent rate when using precision approach pitch and power of line-on-line attitude and 21% torque. Here's the profile view of ILS-17 at Ponca City. As you can see, the approach glide slope brings you in at 3 degrees. The final approach fix, Octay, is 5.1 nautical miles from the runway and approximately 1,700 feet AGL. When visual with the runway, if the runway has PAPIs or VASIs, it is a good idea to use them for descent guidance, especially in low visibility weather conditions or at night. The third and least preferred visual arrival type to an NTA is the overhead pattern. The overhead pattern is described in the AIM 11248 and the T6-1 as seen here. There are several reasons why this arrival type is the least preferred pattern entry. For one, general aviation and business aircraft do not typically fly this type of pattern. Secondly, as was covered in Part 1, AFI 11-2T6 Vol 3 states overhead patterns will not be flown at uncontrolled airfields. When you go to an airfield with an operational control tower on your round-robin, out and back, and cross-country sorties, feel free to request the overhead pattern if you desire to do that type of VFR arrival. Now let's get ready to head to Ponca City. During ground ops, set up the GPS and RMU with all the points and frequencies that you will need. In the GPS, notice the route to the NTA and ILS points are loaded. In the VHF, the Ponca City ASOS and localizer frequencies are in standby. Excellent task management means you are able to stay ahead of the aircraft because you are always thinking about what is next, what is after that, and what can be done in preparation. Here the aircraft is airborne and established on the pod stereo route. Notice that the Ponca City weather is being listened to in the VHF and that the CTAF frequency is in standby. If weather permits, once clear of Woodring's Class D airspace, cancel IFR by saying Texan 13, cancel IFR, NTA Ponca City. ATC will likely respond with cancellation of IFR received, squawk and maintain VFR, frequency change approved. ATC may request you remain on your current squawk and frequency for traffic advisories if you're still somewhat close to Vance and there's traffic along your route. If you do not cancel IFR approaching pods, ATC will call you and say, Texan 13, approaching the edge of my airspace, say intentions. Which is their way of saying, do you want to cancel IFR or do you want to be handed off to Kansas City Center? For this reason, cancel IFR sooner than later when weather permits and you are in Class E or G airspace. After canceling IFR, squawk 1200, proceed direct to Ponca City, and climb or descend to a VFR hemispheric altitude. Once you have Ponca City's automated weather, monitor Ponca's common traffic advisory frequency. UHF is not needed, so as a technique, switch to memory channel 18. 10 miles from the airfield, make an initial radio call over CTAF, advising other traffic of your position and intentions. Highlighted here are some of the key points AC 90-66B states about NTA radio communication. An example radio call is Ponca City traffic, T6 Texan 2, 10 miles southwest at 2,500 feet, inbound for right downwind runway 17, Ponca City. This is also a good place to start slowing and descending to your traffic pattern airspeed and altitude. On this flight, winds favor using runway 17. Since we want to start with pattern work and landing practice, let's plan to enter the downwind leg at a 45-degree angle. If, however, winds favored runway 35, the arrival and pattern entry would look like this. Here, the aircraft is on a northeast heading with the airfield approximately 3 miles off the nose. The aircraft is set up to enter a midfield right downwind for runway 17 at a 45-degree intercept angle. The aircraft is now established on downwind with proper 3/4 mile spacing from the runway. There is no other aircraft in the pattern, so on this pattern the aircraft is 1,000 feet AGL. Keep in mind turboprop should fly the visual pattern at 1,500 feet AGL, which is imperative to do if there are smaller and slower aircraft in the pattern. Perch like normal when at a 45-degree angle from the threshold. Here the aircraft is based to final for 17 at Ponca City. Now let's discuss conducting a VFR straight-in at Ponca City. This can be done strictly using ground references, known as pilotage, or with electronic navigation assistance. Most pilots elect to do a combination of both. The way in which you get yourself to final and the altitude in which you start a constant 3-degree descent is up to you. Here we are applying the 60-to-1 rule and starting our descent 5 miles from the runway at 1,500 feet AGL. Notice precision approach, descent, pitch, and power are being used. As discussed earlier, you can use an instrument approach plate to assist you with VFR straight-ins. The nice thing about an instrument approach plate is the distances, final approach fix, and minimum altitudes are already created, taking some of the guesswork out of visual navigation. Using the GPS 17 approach plate at Ponca City, you can position yourself on a 5-mile final at 2,700 feet MSL and then start your descent for a visual straight-in. Another straight-in method you may consider using is doing like we do at Eastside or Kegelman. If you look at the in-flight guide diagram, you'll notice outside downwind is approximately 3 section lines from the runway. Also notice the descent from 1,000 feet AGL and turn occur approximately 4 section lines past the runway threshold. From your straight-in academics, you'll recall you configure somewhere between 5 and 2 miles from the runway. The Eastside and Dogface straight-ins are designed to put you 500 feet AGL until 1.5 miles final. If you're doing straight-in patterns at NTAs or tower-controlled airfields other than your home base, you can adjust leg length and altitudes as you desire. For example, at Ponca City, you could position yourself on a 3-mile final, configured, at 900 feet AGL, then start your descent to the runway. If the NTA does not have an instrument approach procedure, you can still use the GPS to assist you with straight-ins. One easy thing you can do is put the airfield as the active waypoint in the GPS. Then, select OBS and spin in the runway course. At Ponca City, landing runway 17, spin in 170 as the approach course. With this method, you will have approximate course guidance and distance from the runway. You can also create your own final approach fix in the GPS if desired. This process requires naming the point using a letter, number, or both that doesn't already exist as a point in the GPS database. You will have to input a reference point, whether that be an airfield or nav aid, and the desired radial and DME from that reference point. This process of creating your own waypoint involves pushing the enter button about a dozen times. Here's an example of how to create a waypoint 3 miles north of Ponca City. Now a quick look at shooting the ILS-17 approach at Ponca City. Here the aircraft is on base leg for the ILS. An instrument approach, whether flown IFR or VFR, is a great option for getting into the visual traffic pattern via a straight-in. IFR traffic does not have priority over VFR traffic at NTAs, and all pilots are responsible for collision avoidance. As seen in AC 90-66B, pilots should communicate on CTAF and maintain aircraft separation and safety regardless of whether IFR or VFR at NTAs. On the topic of CTAF and position reports, phrase your radio calls so that non-instrument rated pilots can understand where you are and what your intentions are. For example, when on final approaching the final approach fix, your radio call should sound something like Ponca City traffic, T6 Texan 2, 8 miles straight in ILS-17 approach, Ponca City. If you happen to be circling to 3-5 due to winds, your radio call could sound something like Ponca City traffic, T6 Texan 2, 8 miles north of the airfield, will be entering the left downwind for runway 35, Ponca City. To depart Ponca City, fly runway heading or at a 45-degree angle towards the traffic pattern. Once above 1500 feet AGL, turn on course and continue climb to an appropriate VFR altitude. If going back to Vance, weather permitting, 4,500 feet or 6,500 feet MSL are good options to transit under the east MOAs. If you plan to go to an east or north high MOA, you can climb to 12,500 feet if well clear of the MOA boundaries. Once well clear of Ponca City, do a guts check and turn on course. Put your local squawk of 42 whatever back into the transponder before calling ATC. Squawking local is for radar identification purposes only. At this point, you are still VFR and must adhere to VFR rules. Now call up Vance Arrival on Uniform Channel 17. Tell them your altitude, location, and request. For example, Vance Arrival, Texan 13, 10 miles southwest of Ponca City, 6,500 feet, request East High MOA. If going back to Vance after Ponca City, you may either return VFR or elect to pick up an IFR clearance again with Vance Arrival. The choice is yours. Locally, going back IFR is as easy as calling up Arrival and saying your call sign, altitude, and location, followed by request recovery eastside, and include the current ATIS identifier. If you would like to remain VFR, instead say Vance Arrival, Texan 13, 6,500 feet, 20 miles east of Vance, request VFR flight following to Echo with information alpha. If requesting VFR flight following to Echo, you can expect Vance Arrival to say Texan 13, maintain VFR to Echo. If electing to be IFR again, expect to be either told clear the Echo recovery via Woodring or cleared Echo. When Arrival needs to sequence you to Echo due to traffic conflicts, you can expect a vector and altitude to provide spacing. Once traffic is no longer a conflict, Arrival will say Cleared Echo. Per the 11-2T6 Vol 3 71st OG supplement, if cleared Echo, you are to proceed direct to Echo and descend to 2800 feet MSL. 5 miles from Echo, make your radio call. Texan 13 Echo. When told to contact tower or east side on channel 4, acknowledge with your call sign, do your guts check, and cross Echo at 2300 feet and 230 knots.